So in this video we are attempting to demonstrate the theorem that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and therefore similar to each other. Okay? Recall that the definition of similarity only requires that two angles of a particular triangle be congruent to another, which is precisely what we're attempting to demonstrate. I have already drawn our right triangle ACD, okay, along with its altitude given as segment EC. Okay? We know, for example, or we are given our right triangle, an altitude, and also I have labeled particular angles. I haven't said what they are, I'm just saying that we already have them. Okay? So we're now going to attempt to demonstrate that for each triangle, there's always at least a pair of congruent angles. So long as you have two sets of congruent angles for any triangle, that's sufficient. We can show all three. Okay? First, what do we know? We know that angle, the right triangle from ACD has a right angle. And that angle is delta plus beta. We know that this is the right angle, basically based on our construction of it. We made it by a perpendicular bisector between 2 points. Okay? So we were given that it has a right angle, which is the sum of these two angles. Okay? We also know that an altitude is perpendicular to the opposite side, which means that epsilon and gamma are 90 degrees. Okay? They are both congruent and 90 degrees by definition of the altitude. Okay? So in each case, our total triangle has a right angle. Each of our other triangles has a right angle as well. Okay? So we now seek to prove that, let's just look at a triangle ADC and EDC. Okay? We know that eta is self-congruent with itself. Okay? This is done by our reflexive property. Okay? Something is always self-congruent. Okay? As such, we know that in triangle ADC, we have a right angle, okay, and we have eta. In triangle ECD, let's see, CDE, okay, we also have a right triangle and an eta. Okay. So because these both exist, and this is more of a reason than a statement, okay, we know that by angle, that triangle ADC is similar to triangle CDE. We have only shown that one of these is true. We now just need to show that the other one is true as well. Okay? So we use a very similar property. Let us show that. Okay. Again, this one just shows that the big triangle and this smaller one are both similar. Let's look at the third one. Okay. We're going to look at triangle ACD again. Okay, so ACD, okay, which we know has both a right angle and angle alpha. Okay. We also look at the other small triangle. Okay. In this case, we look at triangle AEC. Okay. And we notice that it has a right angle, which was gamma here, and it also has alpha. Recall that, and I should have put this before, alpha is self-congruent with itself, again by the reflexive property. Okay? But because our two triangles have two congruent angles, we automatically know that triangle ACD is similar to triangle AEC, okay, by angle. Okay? Since if you know two angles, for a triangle, the third one is automatically determined. You technically know all three angles, which means that all three angles are congruent for all three triangles, which means that all three triangles are similar. So this proves our theorem that if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original and to each other.